Let's now talk about the terms population parameter and sample statistic. A population parameter is a value that describes an entire population. And a sample statistic is a value that describes a sample. Let's look at some examples. Before I do this, actually, let's look back at the last slide. Remember how all of these values here on this left side of the board were calculated with an entire population? Since they were all calculated with an entire population, they would all be called population parameters. So this range right here, this variance, this standard deviation, and this mean absolute deviation would all be called population parameters. These same values over here, the range of the sample, the mean absolute deviation of the sample, and the variance and standard deviation of the sample would all be called sample statistics because they were all calculated with a sample. So let's go back over here. One example of a population parameter is a population mean, which is the mean of an entire population. What could be an example? Maybe the mean GPA of all 20,642,819 college students in the US. If you were able to record the GPAs of all 20,642,819 college students in the US, add those GPAs, and then divide the total by this number right here, your answer would be the population mean. And it would also be called a population parameter because it's a value that is calculated with an entire population. Another example is a population median would also be a population parameter. A population variance, meaning a variance that's calculated with an entire population. A population standard deviation. So if you recorded the GPAs of all of these college students, meaning you recorded the GPAs of every college student in the US, and then you used the answers to calculate a variance and a standard deviation, your answers will be called a population variance and a population standard deviation. And both of them would be called population parameters, just like how the population mean would be a population parameter. What about sample statistics? All of these values here are called sample statistics if they're calculated with data from a sample and not from an entire population. So a sample mean would be a sample statistic. And an example of a sample mean could be the mean GPA of 200 selected college students living in the US. So if I selected 200 college students, I recorded their GPAs, I added those 200 GPAs and divided the total by 200, I would get a sample mean, and that sample mean would be called a sample statistic. Also, if I found the median of the 200 GPAs, my answer would be called a sample median, and that would also be a sample statistic. If I calculated the variance of the 200 GPAs, I would have a sample variance. And if I calculated the standard deviation of 200 numbers, I would have a sample standard deviation, and that would also be a sample statistic. And there's actually symbols that are used for these different values. All of the population parameters have a Greek symbol. The symbol for a population mean is the Greek letter mu, which looks like a U, and it's pronounced this way. We don't talk about median. The symbol for a variance is sigma squared. That Greek letter is called a sigma. And a population standard deviation is just sigma. For sample statistics, they don't use Greek letters. The symbol for a sample mean is x. It's called x bar. It's an x with a bar above it. Sample variance is the letter s squared, and it's just called s squared. And then sample standard deviation is just s. The reason why this is just sigma is because it's the square root of the variance, and the reason why this is just s is because it's the square root of the variance. I won't go over the symbols for median. I wanted to also go over the symbols for sample size and population size. Those don't really fall into these categories, so I'll put them over here. Population size is a capital letter N, and sample size is a lowercase n. And if we wanted to go back to this slide right here, we could use some of those symbols. We said that the mean of the entire population was 66, so it would be mu equals 66. And the mean of the sample came out to 60.33. So over here we could say x bar, the sample mean, equals 60.33. And this was a population standard deviation. So we could say sigma equals 9.61. This standard deviation over here was a sample standard deviation, so we could use the letter s. We could say s equals 4.53. And one of the most important things as we go on is to remember that a population mean isn't the same thing as a sample mean. and also that a population standard deviation isn't the same thing as a sample standard deviation. If you can remember those things, that'll make a lot of the later topics a lot easier. And since we don't collect data from entire populations, since they're too large to collect data from, we hardly ever actually calculate population parameters. For example, no one would actually calculate the mean GPA of the entire college student population in the US. What we actually do is we collect data from samples and we calculate sample statistics. And then the sample statistic helps us get a rough idea of what the population parameter equals. For example, a person who's calculating this sample statistic right here is doing that to estimate what this population parameter over here equals. So the sample statistic estimates the population parameter, and that's just because, like we said, the purpose of collecting data from a sample is to learn about the entire population. And the sample statistic won't be exactly equal to the population parameter, but hopefully it'll be close enough to at least give us a rough idea of what it equals.